Good morning, students. This is Murthy sir. Today, let us learn about the physical and chemical properties of salts and the water of crystallization. Before going through the physical and chemical properties of salts, first let us see what are physical properties. Physical properties can be observed or measured without changing the composition of matter. Physical properties are used to observe and describe matter. Physical properties include appearance, texture, color, order, melting point, boiling point, density, solubility, polarity, and many others. First, let us see the physical properties of salts. Salts form crystals when in solid form. Salts usually have a higher hardness because of their ionic bonding. An equal number of opposite charges makes the ionic compounds neutral with no charge. Salt water is a good conductor of electricity. Salts are ionic in nature due to the presence of ions. Salts are mostly solids which melt as well as boil at high temperatures. Salts are generally soluble in water. Best example, sodium chloride. Some salts are insoluble in water. Example, silver chloride. Now, let us see what are acidic, basic and neutral salts. An acidic salt is formed by the reaction between strong acid and weak base. Examples are ammonium chloride and copper sulfate. A basic salt is formed by the reaction between strong base and weak acid. Examples are sodium acetate and sodium sulfide. A neutral salt is formed by the reaction between strong acid and strong base. Examples are sodium chloride and potassium nitrate. Now let us learn about the chemical properties of salts. Common salt sodium chloride is used as raw material for the extraction of some chemicals. The common salt sodium chloride, which is obtained from seawater by evaporation, is a valuable raw material for the extraction of some chemicals of daily use such as sodium hydroxide, baking soda, washing soda, bleaching powder and many more chemicals. Now let us see what is chlor-alkali process. The chlor-alkali industrial process uses brine, salt water, to produce chlorine, sodium hydroxide and hydrogen. An electric current is passed through the brine to form hydrogen gas at the negative electrode cathode and chlorine gas at the positive electrode anode. In chlor-alkali process, sodium hydroxide solution is also collected at cathode. Students, this is the electrolytic cell in which chlor-alkali industrial chemical process is conducted. This picture reveals that hydrogen gas and sodium hydroxide solution are collected at cathode and chlorine gas is collected at anode. This is the balanced chemical equation for chlor-alkali process. Sodium chloride reacts with water to form sodium hydroxide, hydrogen and chlorine gases. Chlorine gas is collected at positive electrode anode. Hydrogen gas and sodium hydroxide solution are collected at negative electrode cathode. Bleaching powder is calcium oxychloride. The chemical formula of bleaching powder is CaOCl2. It is also called chloride of lime. This white powder is bleaching powder which is used as disinfectant. Bleaching powder is manufactured by passing chlorine gas over dry slaked lime. CaOH twice reacts with chlorine to form CaOCl2 and water. The chemical name of slaked lime is calcium hydroxide. Baking soda is prepared by reaction of cold and concentrated solution of sodium chloride with ammonia and carbon dioxide. Here you can see the chemical reaction, a balanced chemical equation. By heating two molecules of sodium bicarbonate or baking soda, we will get sodium carbonate, carbon dioxide and water. Sodium carbonate is commonly called washing soda. When plaster of Paris is mixed with water, it changes to gypsum. Hemihydrate of calcium sulfate reacts with 1.5 water molecules to form dihydrate of calcium sulfate, which is called gypsum. Dihydrate of calcium sulfate is called gypsum. Hemihydrate of calcium sulfate is called plaster of Paris. The water of crystallization means having a fixed number of molecules present in one formula unit of a salt. Crystal salts with water of crystallization are known as hydrates or hydrated salts. The other names of water of crystallization are crystallization water or water of hydration. Now let us learn about an experiment which proves that water of crystallization can be removed by supplying heat with the help of a Bunsen burner. The apparatus required for this experiment are one test tube, a tongs to hold while heating, and a Bunsen burner. Copper sulfate crystals, hydrated copper sulfate crystals which are blue in color, we have to take in the test tube. When we supply heat with the help of Bunsen burner flame, the water molecules which are present in hydrated copper sulfate, they evaporate and we can clearly see the presence of water molecules on the inner wall of test tube. Blue colored hydrated copper sulfate crystals turn white in color when water molecules evaporate. So anhydrous copper sulfate is white in color. Again, by adding little moisture or few drops of water, this anhydrous copper sulfate turns blue in color. Bunsen burner was invented by German chemist Robert Bunsen. Students, here you can see hydrated copper sulfate crystals which are blue in color and anhydrous copper sulfate crystals which are white in color. Here, hydrated copper sulfate contains fixed number of 5 water molecules. This is an example of water of crystallization. Here you can see some examples of hydrated salt showing water of crystallization. Copper sulfate CuSO4 5H2O, sodium carbonate Na2CO3 10H2O, plaster of Paris CaSO4 half H2O, gypsum CaSO4 2H2O.